Hello friends, today let us discuss about some theorems of moment of inertia. So theorems that are used to determine the moment of inertia calculations. There are two theorems that are used in determining moment of inertia, that are parallel axis theorem and perpendicular axis theorem. So let us first discuss about perpendicular axis theorem. Okay. So the statement of the perpendicular axis theorem is that the moment of inertia of an area about an axis perpendicular to its plane at any point O is equal to the sum of moment of inertia about any two mutually perpendicular axes through the same point O and lying in the plane of the area. Means, for example, suppose this is one plane area, and let us take that we will take three mutually perpendicular axes. Let this be x-axis, this be y-axis, and let us consider that there is one more axis, that is z-axis, which is perpendicular to this plane. Okay, which is perpendicular to this plane, and let be the O be the origin. Then the moment of inertia about z-axis is equal to the sum of moment of inertia of this area about x-axis and about y-axis. That is, here it states that Izz is equal to Ixx plus Iyy. Let us first prove this one. Okay, let us take one y-axis, one x-axis. So this is x-axis, this is y-axis. Then this is the origin O. Then let us take one axis which is perpendicular to this x and y axis, that is towards the observer. Then let us consider that this is the plane figure of which we want to find the moment of inertia, and let us take a small elemental area which is at a distance of, say, y from x-axis and say x from y-axis. Okay, let this area of this elemental figure is, say, dA. Okay, then referring to this figure, if z-axis is normal to this plane of the figure passing through this point O, then according to this theorem, Izz is equal to Ixx plus Iyy. Let us prove this one. Let us consider an elemental area dA at a distance of, say, r from the point O, that is from the point O, this area is at a distance of, say, r. Okay, then let the coordinates of this dA be x comma y. That is, this dA is at a distance of y from x-axis and at a distance of x from y-axis, and it is at a distance of r from the point O, that is about z-axis. Then from the definition of moment of inertia, we know that the moment of inertia about the axis perpendicular to this plane, that is Izz, that is about z-axis, can be written as Izz is equal to what? Summation of distance of this area from z-axis, that is from point O, which is r, hence r square, into the area is dA. Okay. Hence Izz is equal to what? Summation of r square into dA. But from Pythagoras theorem, you can just see here that this is r, this is y. If this is x, then this is also, this distance is also x, because it is parallel to this x distance. Okay. Hence, from Pythagoras theorem, you can see that this is the right angle triangle. Hence, r square is equal to x square plus y square. Okay. That is, r square is equal to x square plus y square. Hence, substituting in this above equation 1, let us call this as say equation 1. So substituting in this equation 1, we get Izz is equal to summation of x square plus y square into dA. Now let us multiply this dA to both this x square and y square. Then we will get it as summation of x square into dA plus summation of y square into dA. Now we know that what is this summation of x square dA? It is moment of inertia of the area about y-axis, no? Hence, this can be written as Iyy plus, what is this summation of y square dA? It is moment of inertia of the area about x-axis. Hence, this is Ixx. Hence, proved. That is, Izz is equal to Ixx plus Iyy. Okay, this is called as perpendicular axis theorem. There is one more parameter called as radius of gyration. Radius of gyration. 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 Okay. Radius of gyration. The radius of gyration of any given area is defined as the square root of the ratio of moment of inertia and its area. Okay, it is the square root of the ratio of moment of inertia and area. Okay, and it is denoted by small k. Hence, small k can be written as k is equal to under root of I by A, where I is moment of inertia of the area and A is the area of that plane figure. Hence, if squaring on both sides and simplifying it, we'll get I is equal to A into K square. That is, the moment of inertia is equal to the area, product of area into square of the radius of gyration. Hence, the moment of inertia about x and y axis can be written as Ixx is equal to what? A into kx square, and similarly Iyy is equal to what? A into ky square. Okay, where kx and ky are called the radius of gyration about x axis and radius of gyration about y axis. If radius of gyration is expressed in terms of polar moment of inertia, that is Ip or Izz, then it is called as polar radius of gyration. So polar moment of inertia IP is what? It is nothing but IZZ. It is used for circular figures, which will be IXX plus IYY. But for circular figures, IXX and IYY will be equal. Hence, it is IP is equal to 2 times of I. Okay. It is IP is equal to 2 times of I. That is moment of inertia. Hence, this IP is called as polar moment of inertia, and the radius of gyration used IP is equal to A into Kp square. It is called as polar radius of gyration. Okay. Okay. Now, in the next class, let us discuss about parallel axis theorem used in moment of inertia calculations.